In this lesson, we're going to focus on an important characteristic or two important characteristics of a linear function. That is our x-intercept and our y-intercept. So first, let's focus on the x-intercept. So your x-intercept is going to be where the line crosses the x-axis. So when we take a look at the graph above, our x-intercept, the point where our line crosses our x-axis, is here. This is our x-intercept. And to name this intercept, we just name the ordered pair where the line crosses the x-axis. That ordered pair would be the ordered pair 1, 0. If we were to find the x-intercept algebraically over here on the right, we would need to substitute 0 in for y and then solve for x. So let's take the equation y equals 2x plus 4. So to algebraically find that x-intercept, we're going to replace y with 0. So we'll have 0 equals 2x plus 4. Then we solve it. Subtract 4 on both sides. We get negative 4 equals 2x. Divide both sides by 2. And x equals negative 2. So our x-intercept, the line crosses our x-axis at the point negative 2, 0. If you notice, in both examples, our ordered pair, the the y value was 0. So both on the graph and algebraically, when we found the x-intercept, y equaled 0. Now let's focus on the y-intercept. So again, looking at the graph first, we can see that our y-intercept is where the line crosses the y-axis. So looking at the graph, that would be this point here. That is our y-intercept. And if we were to name that ordered pair, that's the ordered pair 0, 1. So our y-intercept is 0, 1. Now algebraically, to find the y-intercept, you want to substitute 0 for x and then solve for y. So almost thinking of it as like the opposite of the x-intercept. So taking the linear equation, y equals 3x minus 1. To find the y-intercept, we're going to replace this x with 0. So that would give us y equals 3 times 0 minus 1. That would be y equals 0 minus 1, because 3 times 0 is 0. 0 minus 1 is negative 1. So the line is going to cross the y-axis at the point 0, negative 1. Now if you notice, our y-intercept for the graph and our y-intercept algebraically, both x values were 0. So when we're finding our y-intercept, x always equals 0. Now taking a look at the next page, we have several examples where we're going to find these intercepts algebraically. So if we look at this first example at the top, y equals x minus 5. To find the x-intercept, remember y equals 0. So we're going to substitute in 0 for y in that equation. So that would be y equals x minus 5. Add 5 to both sides, and x equals 5. So our y-intercept is 5, or the point 5, 0. Now the y-intercept, remember that's when x equals 0. So we're going to replace x with 0 in this example. So that would be y equals 0 minus 5. We know 0 minus 5 equals negative 5. So our y-intercept is the ordered pair 0, negative 5. Now go ahead and yellow highlight the other examples. Y equals 3x plus 9. Y equals 1/2 x plus 2. Y equals 3/4 x minus 6. And remember, when you're solving these, it's important to remember that your x-intercept, you substitute 0 for y. And then for your y-intercept, you're going to substitute 0 for x. So you almost want to think about it being the opposites.